Now let's take some of the important problem based on engineering mechanics. So I am taking a problem which is based on resultant. So problem based on resultant force. Resultant force. So first of all, I will write the problem. So in problem, two forces act at a point. Two forces act at a point. The first force has x and y component, x and y components of 3 Newton and minus 5 Newton respectively. The resultant of these forces, the resultant of these forces has a magnitude of 2 Newton and acting in negative x direction. Acting in negative x direction, find x and y components of the second force. So I will again repeat the problem. In problem, two forces are acting at a point and the first force is having x and y component, that is 3 Newton and minus 5 Newton respectively. The resultant of these forces has a magnitude of 2 Newton and acting in the negative direction. We have to find out x and y component of the second force. So now let's solve this problem. So for solving, if we draw the diagram, then it will be very easy. So first I will take first force. Suppose first force is P1 and the second force is suppose P2. So here the component of P1 in x direction. So I will write x component of P1, that is P1x, and it is given, that is 3 Newton. Similarly, y component of P1, that is P1y plus 2 minus 2. Minus is showing it is acting negative y direction. Similarly, assume x component of P2 is P2x and y component of P2 is P2y. So now we are having P1x, P1y, that is the component x and y component of P1, and P2x and P2y, that is x and y component of the second force. And assume R is resultant. So x component of resultant equals to Rx, and here the resultant will act in a negative x direction and the magnitude is 2 Newton, so minus 2. Similarly, y component of resultant will be Ry, and it will be 0 because the whole resultant is acting in negative x direction. It means the component of resultant in perpendicular direction, means in y direction, will be 0. Now I am drawing the diagram here for our clear understanding. So this one is our axis. Here we are having positive x. Here we are having positive y, negative x and negative y. So now we are having the component P1x. The x component of P1 is acting in a direction, positive direction. So this one will be the 3 Newton here. Similarly, the y component, it is acting in negative y. So here it is 5 Newton because it is acting in the negative direction. So I am showing in the negative direction here. Similarly, the resultant will act in a negative x direction here. That is 2 Newton. So this one is 2 Newton here. Write the equation in terms of component, then it will be very easy. So I can write x component of resultant equals to x component of P1 plus x component of P2. So x component of resultant, it's nothing but Rx. X component of P1 nothing but P1x. X component of P2 is nothing but P2x. So Rx, we know the value of Rx is -2. I am putting -2 here. We know the value of P1x, that is 3 Newton. We have to find out P2x. So P2x will be -2 -3 is to -5 Newton. So the x component of P2 will be -5 Newton. And write equation for y component. So y component of resultant equals to y component of P1 plus y component of P2. So we know the y component of resultant is Ry, y component of P1 is P1y, y component of P2 is P2y. So we know the Ry is 0, the P1y we know that is -5. So we can calculate P2y. So by this equation P2y will be 5 Newton. So the y component of the second force P2 will be 5 Newton. So by this way we can find out the component of second force, that is P2x and P2y. So I will again write the answer. P2x will be -5 Newton and P2y will be 5 Newton. So -5 and 5 will be the correct answer. Let's take another problem based on truss. Problem based on truss. So for this problem I am just drawing the truss for our understanding. So I am now drawing the members of the truss. So this one is the given truss. I am just drawing the members here. So these are the members of the given truss, and we are applying a load of a force of 1600 Newton here and 800 Newton here, and these points are A, B, C, D, E and F, and the distances are given. This one is 6 meter, this one is 8 meter, this one is 8 meter, and this uh, truss is supported by two supports with one roller support at C and hinge support at D. So now this one is the complete description of the truss, and we are interested in force in member DE. Member D. So our interest is we have to find out force in member DE. So first of all we have to identify the support and we have to mark the reaction. So there are two supports. At C there is a roller, so we know there is only one reaction will be there, that is RC. And at D it's a hinge support, so there will be two reactions, one in X direction and second one in Y direction. So suppose in Y direction it is R dy, and in x direction it will be rdx. So we are assuming RC, RDX and RDY. So now we have to find out these reactions. So for finding the reactions, we have to apply the conditions of equilibrium. So let's apply the first condition, that is algebraic summation of all horizontal forces should be zero for forces along x direction. So I am just writing our sign convention. Positive x here is positive, that is x. Positive y is positive, negative x is negative, negative y is negative. So here the 1600 Newton force is acting in negative direction, so minus 1600, plus rdx, that is acting in a positive direction. Only these two forces are acting in next direction is to 0. So by this way we can find out rdx is 1600 Newton. So this one is the value of rdx. Similarly, we can apply the condition number 2, that is algebraic summation of all vertical forces should be 0 for forces along y direction. If you see here, the 8000 Newton is acting in downward direction, means in negative y direction, so minus 800. Similarly, RC here is acting in upward direction, so plus RC, and RDY is also acting in upward, so plus RDY equals to 0. So I will get RC plus RDY equals to 8000. So this one will be the equation which shows the relation between RC and RDY. That is nothing but RC plus RDY equals to 8000. Now let's take an condition number 3, that is algebraic summation of moments of all the force above D should be 0. I am considering the point D here. So I am considering the equilibrium equation, that is algebraic summation of moments of all the force above D should be 0. If you see, the rdx and rdy is passing through D, so the perpendicular distance is 0, so the moment is 0. So I can write rdy into 0 plus rdx into 0 because perpendicular distance is 0. If you see the line of action of 8000 Newton force, it will pass through D. So the perpendicular distance for 8000 Newton force will again 0. So moment will be 0. So 8000 into 0. Similarly, if you see the 1600 Newton force, so the perpendicular distance will be 8 into 8 plus 8, that is 60. Because this 60, so the moment due to this 1600 Newton at D point will be 1600 into 16, because 8 plus 8 60, and the direction is in anti-clockwise direction. So according to our sign convention, clockwise is positive, anti-clockwise is negative. So I am putting negative sign. Similarly, due to this RC, moment at D will be RC into this perpendicular distance, it is nothing but 6 meter. So I can write RC into 6, and the motion is in clockwise direction, so positive equals to 3. So I will again rewrite this thing. 6 RC equals to 1600 into 16. So RC will be 1600 into 16 by 6. So we will get RC equals to 4266.7. So our value of RC is 4266.6, 4266.7. So by this way we can find out the value of RC. So the relationship between RC and RDY, that is RC plus RDY equals to 8000. So here I can put the value of RC, that is 4266.7. So I can write 4266.7 plus RDY equals to 8000. So RDY will be 8000 minus 4266.7 equals to 3733.3 Newton. So the value of RDY is 3733.3 Newton. So now we have calculated the reactions at the support C and T. But we are interested in the force in member DE. So let's draw the free body diagram of joint D. So FBD of joint D. So at joint D, there are two reactions. One is RDY. We know the value of RDY, that is 3733.3 Newton. And one is RDX. We know the value of RDX also, that is 1600 Newton. And there are two members. So according to our assumption, the forces in the members are tensile. So arrow will be away from joint. And force is FDE. Away from joint. So this force is FDC. So we have to apply condition based on y direction. So the equilibrium condition based on y direction is nothing but algebraic summation of all vertical forces should be 0, or forces along y direction should be 0. So FD is acting in upward direction, so it's positive, so plus FDE, and RDY is also acting in upward direction, so plus RDY equals to 0. So FDE plus the value of RDY is 3733.3 equals to 0. So FDE is minus 3733.3 Newton. So negative sign indicates the nature of the force in member DE is compressive. So I can again write like that. FDE is magnitude is 3733.3 Newton and nature is compressive. So this one is the required magnitude as well as nature of the force in member DE. Now let's take another problem based on kinematics. So problem based on kinematics. So I will just write the problem here. A train accelerates from rest at a constant rate alpha for some time, and then it retards to rest at a constant rate beta. Find total distance covered by train during the course. So here I will again repeat the problem. Here a train accelerates from rest at a constant rate alpha for some time, and after that it returns to rest at a constant rate beta. We are interested in the total distance covered by train during this course. So let's solve this problem. For the kinematics problem, if we draw the graph between velocity and time, then we can easily find out the distance, because the area under velocity time graph will represent the displacement, and suppose it's a straight line motion, so displacement and distance will be same. So we can say that the area under velocity time graph will represent the distance. So let's draw the velocity time graph for this train. So on y-axis I am taking the velocity, and x-axis I am taking the time. So the train starts from rest, means from O, and It is accelerate at a constant rate for some interval of time. So this time interval we can say that it is t1, and then it returns to rest in another time interval. Suppose it is t2. So I am just giving the point O, A and B, and this one is C. So I am having the triangle, two triangles are there, OAC and ACB. And if you see this, for accelerated motion, we can write acceleration is nothing but change in velocity by time. So this one is nothing but here it is v. So now I can write for accelerated motion, for accelerated motion OA, I can write acceleration, that is alpha, is nothing but velocity by t1. Similarly, for retarded motion AB, I can write beta is to v by t2 because corresponding time is t2. Now we have already discussed area under the graph velocity time will represent the distance. So total distance, I can write area of triangle OAC plus area of triangle ACB. So total distance, suppose S. Area of triangle OAC is nothing but 1 by 2. Base is T1 and height is V. Similarly, for ACB it is 1 by 2. Base is T2, height is V. So I can write here 1 by 2. In place of T1, I can write V by alpha. Similarly, in place of T2, I can write V by beta. So I will show you how this T1 equals to V by alpha can. Here if you see alpha equals to V by T1, so I can write T1 equals to V by alpha. Similarly here I can write T2 equals to V by beta. So by this way the expression of T1 and T2 comes in terms of V and alpha and V and beta. So that is it. So S will be 1 by 2 V square by alpha plus 1 by 2 V square by beta. If we take V square by 2 common, then we can get 1 by alpha plus 1 by beta. So again simplify it, I will get V square by 2, that is alpha plus beta divided by alpha beta. So this one is the desired expression of distance traveled by the train during this course. Now let's take another problem based on kinetics. So problem based on kinetics. So I am just writing the problem here. A body moves along a straight line, and the variation of its kinetic energy with time is linear as shown in figure. Find relation between force and velocity. So here in this problem, it is mentioned that a body is moving along a straight line and the variation of kinetic energy with time is linear, and we are interested in relationship between force and velocity. So I am just drawing the diagram here. This one is kinetic energy on y-axis, that is denoted by K, and this one is time, denoted by T. the variation is linear. So for the straight line or linear variation, I can write kinetic energy is directly proportional to T. So for kinetic energy, we know the formula for kinetic energy. That is nothing but 1 by 2 mv square is directly proportional to T. Suppose or assume displacement is x. Displacement is x. So for velocity, we can write dx by dt. It is nothing but rate of change of displacement with respect to time. So here I can write dx by dt in place of v, directly proportional to t. So here, if I differentiate both the sides with respect to t, so I will write on differentiating both sides with respect to t, then I will get 1 by 2 and differentiation of dx by dt square with respect to t will get dx by dt and then d square x by dt square, and here the differentiation of t with respect to t will be 1. So I am getting m dx by dt d square x by dt square. So I am getting this thing. If v equals to dx by dt, then acceleration is nothing but rate of change of velocity with respect to time. So for acceleration, I will have d dt of dx by dt is nothing but d square x by dt square. So I can write like that m d square x dt square dx dt proportional to 1. So m in place of d square x by dt square I can write a, and in place of dx by dt I can write v. So now I can write ma is 1 proportional to 1 by v. So ma, we know f equals to ma, so I can write f in place of ma is proportional to 1 by v. So this one is the relationship between force and velocity. So I can write force is inversely proportional to velocity v.